Don't have to say anything else. That was the commercial. Enjoying some Dunkin' Donuts coffee in the morning. Oh my God. Oh, Dunkin' Donuts, you're missing out on a wealth of amazing, amazing commercials. All right, my name is Mr. Krause. I know I tell you that every day. You don't care. We are doing Unit 1, 13, Day 13 notes, sequences, and series. So, yeah, let's just play around with this stuff. Let's get going. Let's just rock and roll. What do we got going on here? All right, this is just a little bit of fun stuff. So you know, calculator value, oh, whatever. Okay, so we're going to do f of 2. We can do this in our head. Let's do f of 2. So you know we're going to sub in. We just sub into 2, and we go 2 squared plus 6 times 2. Notice when I sub in, I always use parentheses. It's usually a good idea. Why don't you do it? Huh? Yeah, why not? This is 4 plus 12 minus 8. 12 minus 8 is 4, plus 4 is 8. Now, if I have the calculator open, which I do, let me show you a real quick way to check that. Move that down so I can see that, right? So we go into calculator mid. If you take mid, you do control var, so it's in blue here, x. Just store, oh yeah, I want to actually press the X button. Thought I did. And then press enter. And then just type this in originally as it appears. You're going to do x squared. Hopefully the x works. X squared plus 6x minus 8. Now the last video I made like 6 mistakes. They were all on purpose. Whatever. All right. So, you know, I could call it f of x. I could call it a of n. So I would do a of 4. And I would do 6 times 4 minus 2, and that would be 24 minus 2, which would be 22. And I can do it that way too. I'm not going to bother checking that one. Now, this is read a of n. This is read f of x. Today we're going to learn a little bit different notation. It's sequence and series notation. And we're going to learn to talk about rules to define sequences and series of numbers. All right, so a sequence is simply a set of numbers that follow a pattern or rule. All right. It's kind of similar to a function that you use to evaluate, but usually just evaluate one number or another number. These are going to be like distinct numbers. When we have a function, it's usually, you know, a line or parabola or an absolute value or something like that. This is a little bit different. It's just different notation, okay? And these are distinct or disjoint numbers, discrete numbers. The word's discrete. Discrete numbers. This number, then this number, then this number, and this number. And you're going to create a series of numbers that are all derived from a sequence or a rule. Excuse me, from a pattern or some kind of rule that dictates how do you go from one number to the next. We'll talk about it. It's not a big deal. All right. So we're going to talk about 2 different kinds of sequences. We got a finite sequence. Finite sequence. And this just ends. It's a sequence that ends. It has a first and last number. Okay? Or we have an infinite or an infinite sequence. I don't know why my handwriting is so bad today. Let me see if I can fix this. Oh, that got much better. Sequence. This does not end. Never ends. It just goes on and on and on and on. And I'll show you what that looks like. It never ends. So it has a first number, but no last. There's a space in between. That's not the word but no. I've just created the word but no. Sounds like I'm saying something wrong. So it's but no last. And if I put the last close, I could have but no last. That's a new word. All right. So a sequence is really just a rule or kind of an equation, but we're going to write it a little bit differently. So I want you to notice how this looks different. I'm going to use A, and we usually use A for, I don't know why, we always just use A, equals 3n plus 2. Now that looks like it's function notation, but I really want you to pay attention that this is sequence notation. So it's similar to a function, except a function would have like, that would be a continuous line, where this is, you plug in a 1, you get 5. You plug in a 2. Let me change pens. You plug in a 1, so when n equals 1, you get the number 5. When n equals 2, you get the number, let's see, 6 plus 2 is, what is that, 8? And when you plug in n equals 3, you get 11, and so on and so forth. So this would be the sequence of numbers 5, 11. I forgot 8. Oh, it's going to be a long day, kiddos. Woo, you know what I need, don't you? A little more coffee. 8, 11, 14, and ... But it's not every single little tiny number in between. It's you plug in n equals 1. That's the first term in the sequence. You plug in n equals 2. That's the second term in the sequence, and so on and so forth. So, you know, if you were to do the first 4 terms of this, the first 4 terms, and now it says terms, I probably shouldn't be using terms, but the first 4, how about the first 4 discrete values, the first 4 values you'd see in your table? Because clearly if you were going to graph this, it would look like this. It would look like this function, where all of these points are being used. Well, that's not what you see in the table. That's not what you see in the table, but it is in fact, because all the little, you know, 1.1, 1.2, 1.3, 1.4, 1.5, it's in the middle there, right? But if I was to do this, I would just do f of 1. You guys know function notation. You'd say, okay, f of 1 is equal to 3 times 1 minus 7, and you would get, what's that, negative 4? And then you do f of 2, and you do 3 times 2 minus 7, and you get negative 1, and you do f of 3. I think you get the picture here. I don't need to keep... Oh man, I keep wanting to use the term beat a dead horse, but it's so vile. And it's from like my grandparents beating a dead horse. I think it might be from great-grandparents back on the ranch or something like that. I don't know where it's from. It's a terrible, terrible statement. So that would be the sequence. Now, how's it going to look for an arithmetic sequence? Or that's for a function. But for an arithmetic sequence, it kind of looks the same. It kind of looks the same. So you do a sub 1. Now that's read, and I should have said that before, and I apologize. The way this is read is a sub n. In other words, a subscript, right? Anytime there's a number on the top, it's called a superscript. Anytime there's a number on the bottom, it's called a subscript. So this is read a sub n. I just don't want you sounding silly when you're talking in the math world. So I would read this as a sub 1. So a sub 1 is equal to 2 plus 1 minus 1 times 3. And this would just be 2. And then I would read a sub 2 would be 2 plus 2 minus 1 times 3. And that would be, let's say, that's 1, 3, 5. That would be 5. And then I would a sub 3, and I'd say 2 plus 3 minus 1 times 3. That'd be 6 plus 2, which is 8. And then the next one would be 11, if you did the next one. So this would be the sequence of numbers 2, 3, 5, 8, 11, and then it would just go on forever and ever and ever. But notice it's not, you know, if I'm graphing a function, we're talking about all the intermediate values in between. We just use those discrete numbers to draw the line, but it includes all the other lines. When you're talking about a sequence of numbers, you're just talking about a pattern of numbers to go from one number to the next, and you're not talking about other numbers in between. And you really shouldn't get any of these wrong, because quite frankly, you can put this in the graphing calculator, look at the table, and it will give you the sequence of values. But we're not going to do that because, man, it's boring. So here's what, ooh, it's got a lot of stuff going on in this one. All right, let me pause. Let me save this and then keep going, okay? When I want to be mistake-free with sequences and series, I drink Dunkin' Donuts coffee. I do. Nailed it! Oh God, that was amazing, amazing, simply amazing. I know you're with me. And by the way, Scott, I think I was just about to start yelling at students, and somehow something happened. Maybe that's karma. But you know, Parsons and Polito. Ooh, that sounds like a law firm. Next time you have Dunkin' Donuts coffee on my little Google Meets thing, we're gonna have problems. You know what I'm saying? Okay, so here's how it works. In an arithmetic sequence, there is a common difference between. I really want to just highlight that, not underline. I just want to highlight it. Just let me highlight it. There we go. Common difference, and it's constant. It is a constant difference between the numbers, and we're going to find that. We call it the common difference. And the common difference, D, I'm going to try to do this on diagonal because I don't know if I'm going to fit this box, is equal to the second term minus the first term. Now the trick is the second term minus the first term has to remain consistent. If it changes, then it's no longer what's called an arithmetic sequence. And we're going to talk about the difference between an arithmetic sequence now, and then later on this year we're going to talk about geometric sequences. So in an arithmetic sequence, we're going to find the common difference between these. So we look for D, and we want to make sure it's the same. So we're going to do negative 3 minus negative 5. Well, minus a negative is really plus, so negative 3 plus 5 is 2. So if, in fact, these all have a common difference of positive 2, in other words, we just keep adding 2, then it is an arithmetic sequence. So let's see. I'll do one more just for fun. We'll take negative 1, which is the third term, and we'll subtract off the second term. Negative, negative makes a positive. Negative 1 plus 3 is 2. And look at these. We're adding 2. We're adding 2. So yes, this is an arithmetic sequence, and the D equals 2. Now let's take a look at these. We're going to take the second term, which is 5, and we're going to subtract off the first term, which is 3, and oh, lo and behold, we get 2 again. But then we're going to take off the third term, 9, and we're going to subtract off the second term, and we get 4. And then we always get those kids that say, but look, if I do the next one, I get 15 minus 9, I get 6. By the way, this should have been a 4. I'm not sure why my 4s always end up looking like that. But look, it's adding 2 every time. I see a pattern. It doesn't matter. These have to be the same. If they are not the same, this is not an arithmetic sequence. Let's take a look at this one. D equals 21 minus 25. That looks like it's negative 4. So if they're all negative 4, in other words, we're going down by 4 over and over again, then this would be an arithmetic sequence, and the common difference would be negative 4. 17 minus 21, that's negative 4. And now I'm just going to look. Oh, yeah, we're going down by 4. Oh, yeah, we're going down by 4. So I would say, yes, this is an arithmetic sequence, and the common difference is negative 4. So sometimes you're going to say, hey, I'm going to say, hey, if this is an arithmetic sequence, I want you to tell me the rule that would generate this sequence of numbers. If it's not, just tell me it's not and why it's not. Okay, so what do we got to do? There's 3 different types of problems. The first type of problem, these are the easy ones. These are the easy ones. I give you the first term. You have the first term. You find D. You substitute D and A into the formula, and you simplify the equation. Oh, by the way, this is the formula. Now, the good news is this formula is going to be on your formula sheet. So if you look on the inside page of the packet that I provided to you, that's the formula sheet that you get on there. It's going to be on the right-hand side about halfway down. And that formula will be there. So what this stands for is A sub 1 is the first term, and D is the common difference. And this is the formula that we're going to use to find or we're going to use it. It's more of a rule rather than a formula that we're going to use to create the arithmetic rule that generates an arithmetic sequence of numbers. Man, that was a lot of words. I'm going to make it a little bit easier for you in a second. So there's 3 types of problems. We go from easy to medium to what? These aren't too bad either. These are fine. These are part 2s and part 3s. We'll come back as I transition from one to the next. I'll come back to these rules. So this first problem I'm going to give you, this is an easy one. So we're going to do an easy one. I have the first term. So the first term is this. So A sub 1 equals 2. In other words, every time you do an arithmetic sequence problem, you need to find 2 things. You need to find A sub 1 and you need to find D. We have A sub 1. We just don't have D. But D is easy to find. You go D equals 9 minus 2, 7. And check it. Are we going up by 7? Yep. Up by 7? Yep. Up by 7? Yep. So we found D. Okay. Now I'm going to write the formula. And I'm going to rewrite the generic formula. A sub n equals A sub 1 plus n minus 1 times. And I always put D in parentheses because when it's negative, it gets kind of tricky. So the 7 goes here. The A sub 1 goes here. And then I just clean it up. That's it, right? So that was part 1. Find D. We did that. Substitute D and A into the formula. I'm about to do that, and then we're going to clean up the equation. You don't always have to clean up the equation, but I like you to. I think it makes it a little bit easier. So here we go. A sub n, get used to listening to it and saying it that way. 2 plus n minus 1 times 7. You can think of this as being the x, and this as being the f of x or the y. Okay, but we don't use that in arithmetic sequences, numbers, notation. Okay, so you sometimes can leave it like that. I just don't like to. I like to distribute the 7. So here's what we're going to do. I'll do this one slowly, and then I'll do the next one a little bit faster. So a sub n equals 2 plus 7n minus 7, because I'm going to distribute the 7 here. And then I'll just write it like this. A sub n equals 7n minus 5. I like to check it real quick. So look up here. If we look up to these things, this is n equals 1, 2, 3, 4. So if I plug a 4 into this equation, I better get 23 out. So 7 times 4 is 28, minus 5, 23. Perfect. And then I said find a sub 19, the 19th term in the sequence. So I didn't leave you a lot of room for that. So where am I going to do it? Let's do it right here. A sub 19 equals 7 times 19 minus 5. Well, 7 times 19, let's see, 7 times 20 would be 140. So this 133 minus 5 would be 128. So if you put that in your calculator, and of course you could always just come over to the old dumb machine and say, hello, dumb machine. I don't need you. I don't need you, dumb machine. And you just go like that, 128. Okay. Sometimes you're going to need it because they're tricky. All right, so we have a sub 1. Again, we're working on easy. That's 57. I need to find D, because these are the two things you always have to find. 45 minus 57 is negative 12. So down 12, down 12, down 12. So I found the D equals negative 12. I got the two things I need. Negative D and a sub 1. So now I'm ready to substitute in. I'm gonna use the same formula, but you guys see where they go. A sub n equals the first term, which is 57. That's the first thing I'm putting in. Plus n minus 1 times. Now watch what would happen if you didn't use parentheses here. Minus 12. Does that look like it's multiplying by 12, by negative 12, or does it look like we're subtracting 12? Right? You all would agree with me, I hope, that it looks like we're subtracting 12. But what we're really... Wow, that's the smartest thing I've ever said. Sorry about that. What we're really doing is multiplying through by negative 12. All right, so let's do this. A sub n equals 57 minus, now we're going to do this, minus 12 n plus 12. So a sub n equals negative 12n plus, oh, there's that number again. Shoot. We should never have that number come up. Okay, plus 69. And I'm going to test it. Number 4. I'm going to plug in 4 and hope I get 21. I'm going to do this in my calculator, though, because I need the dumb machine. So negative 12 times 4, and then plus 69, and I get 21, and that's what I wanted. So we're in good shape. Now I want to do 19, so I'll just hit the up arrow, change this over to 19. And I got negative 159. So a sub 19 is equal to negative 12 times 19 plus 69. And that's equal to negative 159. All right, let me save and I'll be right back. So this is the time we're in class. I'm going to ask you to do this, but we're not in class, so I'm just going to keep going. So in this case, a sub 1 equals 9. And you can look at the D here. D is equal to 5 minus 9, which is negative 4. We've got the D. We've got the a sub 1. We're ready to roll. So a sub n equals 9 plus n minus 1 times negative 4. Now, keep working through that. And what we'll get is, I'm going to speed this up a little bit, but because this is negative 4n. And when I multiply these two together, I get plus 4 plus 9 is plus 13. Done. This one, a sub 1 equals negative 15. D is equal to negative 9 minus, careful here, negative 15. So it looks like we're adding 6. Let's see, add 6, yep. Add 6, negative 3 to 3 is 6. So add 6, so 6 is D. All right, so we're ready. A sub n equals negative 15 plus n minus 1 times 6. Now, when I multiply this, I get 6n. And this is 6 times negative 1, which is negative 6. And negative 15, that makes negative 21. And that's what I have there, 6n minus 21. Okay. So now we're going to see, we're going to go medium level. Now we're going to go medium level. Now I'm not giving you a sub 1. But I am giving you the common difference. So I am giving you, of the two things you need, we don't get a sub 1 this time, but we do find the common difference. We do want the common difference. So this is level 2, right? We need to find D. You have the D, but you don't have the first term. And I just said find D. That shouldn't say find D. That should say find a sub 1. So we'll fix that right now. Sorry about that. All right, so we're going to find a sub 1. And here's how you do it. You're going to substitute into the rule. So the rule is a sub n equals a sub 1, which we do not know, plus n minus 1 times d, which we do know. But we also know one other piece of information. We know that a sub 11 equals 41. So in other words, if n is 11, the term we get is 41. Okay? Well, what are we going to do with that 41? That goes in on the left side. And in for n, this should be 11. The 11th term. In for n goes 11. And then we go in for d. So when we're done plugging all it in, we plug that in, we plug that in, we plug that in. The only thing I have left to find is this, and it'll come out really, really easy. So we just plug in all the information we know. So in for a sub n, which is this 41, we put in 41, equals the thing we don't know, plus 11 minus 1 times d, we said was 5, 5. So this is 41 equals a sub 1 plus, now this is 10 times 5, which is 50. Subtract 50 from both sides, and I get a sub 1 equals negative 9. So now I have the two things I need, and I'm ready to write my formula. We're going to go a sub n equals negative 9 plus n minus 1 times 5. Now we'll just clean it up real quick. This is 5n. Now this is minus 5 and minus 9, so that's minus 14. Now I'm just going to check it real quick. I want to plug in 11 and verify I get 41. So 5 times 11, that's 55, minus 14, that would be 41. So we're good. All right. Let's do this. We've got the 15th term, and we've got our d, but we don't have a sub 1. So we're looking for a sub 1 again. We have the d equal to 12. And we have the 15th term as 107. So again, we're going to use this formula. A sub n equals a sub 1 plus n minus 1 times d. Yeah, oftentimes I put the d in parentheses. So we have this, that's 107. We have this, that's 15. And we have the d, that's 12. So we're going to put all those pieces in, and then we're just going to solve for a sub 1. So 107 goes on the left, is equal to, we don't know, plus 15 minus 1 times 12. So 107 is equal to a sub 1 plus, now this is 14 times 12, which I believe is 168. Subtract 168, and I think you get negative 161. I'm going to check all this math in a second. So let's go over to my calculator real quick. You can pause it if you want. I'm going to go with my oh man, that's not my calculator. Here's my calculator. So 12 times 14 should be 168. Yep. And then we're going to take 107 minus 168, and you get negative 61, not negative 161. What am I doing? Negative 61. Okay, so we found the first term. Sure. All right, we're ready to roll. We got what we need. We got those two things now. So a sub n equals negative 61 plus n minus 1 times 12. I'm going to check this out. A sub n, I'm going to clean this up, that's 12. So that's 12n minus, so we got minus 61 and minus 12. So that's what, minus 73? Now I'm going to check this. I'm going to check this real quick by plugging in 15. I'm just going to do it on my calculator. 12 times 15, that's 180 minus 61. Oops, excuse me, 73. And I'm hoping that it's 107. It is. Good. And then they asked me to find a sub 22. So I'm just going to change the 15 to a 22. And I get 191. So a sub 22 is 191. Hopefully I didn't do that too much behind my head. I'll have to take a look at it. All right, now we're going to get to the more tricky ones. And by the way, this is a mistake. Oh, shoot. I believe, what did I make this? When I'm about to tackle impossible arithmetic sequence questions and drink the coffee because it makes me feel mathy. Genius. Absolute genius. Oh my God. Anybody got any contacts with Dunkin' Donuts? I'm sure that they would love to hear from me. I screwed up there. That should be a sub 15. So the 15th term is 5. And the 10th term is 25. So the question is, do we have a sub 1? Nope. Do we have D? Nope, we don't. Now, this one's not so bad to find D. You'll find in a minute. But they get kind of cray-cray. So what we have is, we have the 10th term is 25. And the 15th term is 5. Now, I can count on my little fingers, but that's kind of a pain in the neck. So here's how we do it. What we're going to do is this. D is going to be equal to, it's kind of like rate of change. It's kind of like slope. We're going to subtract the 25 minus the 5 on top, the y values, and we're going to subtract the x values on the bottom, 10 minus 15. Now you're going to notice this is negative, and we're going to talk about that in a second. So this is 20 over negative 5, so it looks like my D is negative 4. And that should make sense. So if you did this, if you took 25, you went 25, subtract 4, you get 21. Subtract 4, you get 17. Subtract 4, you get 13. Subtract 4, you get 9. And subtract 4, you would get 5. So the 10th term, if this is the 10th term, 10th, 11th, 12th, 13th, 14th, 15th, notice it's going down. So that's the D value. Because it was going down, I don't know why that did that. Because it was going down, we're going to have a negative D value. So now we have one of the two things we need. Now it goes, once you find the D, now we're going to the medium level questions. And the medium level questions were like what we do before. We just pick one that we like. And I'm going to pick this one. It doesn't matter because 10's an easy number. 10's easier to work with than 5. So I'm going to use this formula, a sub n equals a sub 1 plus n minus 1 times D. I'm going to plug this in here because now I have that. Here's what we're looking for. We're looking for a sub 1. All right, so let's see. I'm going to use this one right here. So in for the left side is the term. That's the term goes on the left side. So that's 25 equals a sub 1 plus. In for n goes the 10. 10 minus 1 times negative 4. All right, so we get 25 equals a sub 1. This is 9. 9 times negative 4 is negative 36. Now, our first term should be quite a bit bigger than 25, right? So if we add 25 to both sides, or excuse me, add 36 to both sides, What do we get? 61. So a sub 1 equals 61. Now I definitely am writing either way too big or I didn't give you enough room. So let's see what we got here. Now we have a sub 1 and we have d. So now we're going to write our formula. We're going to use this and we're going to plug in d and we're going to plug in a sub 1. So a sub n, I'm going to try to write small here, equals a sub 1 is 61 plus n minus 1 times negative 4. So what we get is a sub n equals negative 4n. Now negative 4 times positive, negative 1 is positive 4. Plus 61 is plus 65. Now I would always check that. I'm going to plug in 10. Go back to your calculator. Do it real quick. Negative 4, negative 4 times 10 plus 65. 25. So when I plug in a 10, I get 25. When I plug in a 15, I better get 5. Negative 10 times 15 plus 65, I get 5. So I checked it and it's right. All right, let's do another impossible one. Here's how it works. We need to find a sub 1 and we need to find d. You're going to find d first. So we're going to go d equals, subtract the terms on top, 20 minus 35. Now wait a second. I don't like that because it's negative. So I'm going to turn that around. I'm going to go 35 minus 20. So I went 35 minus 20. So now I'm going to go 22 minus 17. You just got to stay in the same order. As long as you stay in the same order, we're pretty good. So what do we got here? 15 over 5. So that's a difference of 3. So our d value is 3. So we found that. We're good. We're halfway there. So now to go to the medium level questions, we're going to substitute in using this formula right here. Now pick one. This one looks pretty nice. We'll use that one. It doesn't matter. The term goes on the left, 20 equals, we don't know a sub 1 plus 17 goes into parentheses because that's the n value. 17 minus 1 times 3. So this is 20 equals a sub 1 plus 16 times 3. Everybody knows that's 48. Subtract 48 from both sides and I get negative 28 equals a sub 1. So now we have the two things we need. We have the two things we need. And now we can write our formula in hot fuchsia pink. A sub n equals negative 28, the first term, plus n minus 1 times 3. And we'll clean that up. A sub n equals 3n. I always put the n first. 3n. Now this is going to give me minus 3. Minus 3 and minus 28 is minus 31. And there is my answer. Now, I'm going to check it. I'm going to plug in 17. So I'll do 3 times 17. 3 times 17 minus, oops, shoot, I went to the wrong thing. Minus 31. Boom, 20. Perfect. 3 times 22 minus 31. Boom, 35. Boom, worked. All right. So it's your turn. Oh, wait. Oh, so now there's just some practice. Lots of practice. So if you got it, you're good, but I would suggest you keep practicing. So this one's easy. We're going to start with easy. I give you the a sub 1. I'm giving you a sub 1. And you got to find d. So a sub 1 equals 12. D equals, look, I'm adding 6, adding 6, adding 6. D equals 6. Remember how these are easy ones, right? Now I just plug in the formula. A sub n equals 12 plus n minus 1 times 6. You don't have to memorize that formula. It's on your formula sheet. A sub n equals, this is 6n. And then this would be minus 6. So this would be minus 6 and plus 12 is plus 6. Check it. Plug in 4. 6 times 4 is 24. Plus 6 is 30. We got it. All right, here we go. A sub, let me get a different pen. We'll go with, let's go with green. A sub 1 equals 120. Green's a little fat. Am I allowed to say that? I think I can say that. A sub 2, not A sub 2, N, D is, what are we doing here? Looks like we're subtracting 15, subtracting 15, subtracting 15. I mean, you could check it, 105 minus 120, but that's subtracting 15. So, we got our D, and we got our A sub 1, so we'll just, now we're ready to go for the formula. 120 plus n minus 1 times negative 15. A sub n equals, now that's negative 15n. Now negative 15 times negative 1 is positive 15, plus 120 is plus 135. I'm going to check it. Might need to use my calculator. I'm going to plug in 4. So negative 15 times 4 plus 135. And I'm hoping this is 75. It is. We're in good shape. Okay, so that's easy. Here's medium. Medium, I'm not giving you A sub 1, but you have D. And we're going to find the rule. So we're going to use this piece of information. N equals 8. So we're going to use our formula. A sub n equals A sub 1 plus n minus 1 times 7. 66 goes in here. We don't know A sub 1 because that's the thing we're looking for. In for n goes 8. And I already put the D in there. I should have not put that D. I should have made that D. And then put in 7 here. All right, so what do we got? 66 equals A sub 1 plus 7 times 7. This is 7 times 7 is 49. Subtract 49. What does that get us? 15? No. 17. 17. I'm going to check it anyway, see if my math's all messed up. So we now have A sub 1. A sub 1 is 17. So now I can write my formula. A sub n equals 17 plus n minus 1 times 7. Clean it up. I get A sub n equals 7n. This is minus 7. And then 17, that's plus 10. Now I'm going to check it. If you plug in 8, what's 7 times 8? 7 times 8 is 56, plus 10 is 66. Perfect. So this is medium. This is also going to be medium. It's only medium, but it's also big numbers. So, ooh, they're so scary when they're so big like that. They're so scary, Mr. Krause. I hate big numbers. Big numbers are scary. I'm scared. I'm scared. Let's see. Common difference is negative 10. We know that n equals 25, and this is the term, so this is what's going to go on the left. I'm just going to use the same formula. So 310 equals A sub 1, which I don't know, plus n minus 1 times negative 10. Now, if I'm going too fast, you want to be pausing this, especially on these, and trying them on your own. Oops. Forgot to plug in my n. My n is 25. All right, see what we got here. 310 equals A sub 1 plus, let's see, this is 24, positive 24. Positive 24 times negative 10 is negative 240. I'll add 240 over, so that means I get 550 equals A sub 1. Mr. Krause, those numbers are huge, Mr. Krause. I'm scared. Hey, I think I got it right. So, now we're ready. We have A sub 1 and we have D. So, A sub n equals 550 plus n minus 1 times negative 10. We'll clean this up. A sub n equals negative 10n. Now this is plus 10. So plus 560. So now we got to check our work. So I'm going to go negative 10. Where's my mouse? Negative 10 times 25, because n is my 25, plus 560. That ought to give me 310. And it does. See how it gives me 310? All right. I'm going to pause. I'll be right back. All right, kiddies, we got now 4 hard questions. Now, again, this is a really long video. If you think you got this, go do the homework. If you need more practice, that's what I'm here for. These are 4 very difficult questions. This is the hard level. This is where I don't give you a sub 1 and I don't give you d. So, we got to find a sub 1 and we have to find d. All right, d's first. So d equals, we'll subtract the terms. I'm going to try to stay positive, so I'll go 152. You know, stay positive in your life. Stay positive in math. I went this direction, so I got to go this direction. 40 minus 35. That's the easy part. That's 5. Let's see. What's that, 40? 152 minus 112 is 40. So my common difference is, in fact, 8. Oops, what am I doing? Just want to bring that up a little bit. My common difference is 8. Okay, now I got to find a sub 1. So let's see. This looks like it's a nicer one to work with. I have no idea. So we're going to do 152 equals a sub 1, which we don't know, plus 40 minus 1 times 8. I've now come to the end of my math knowledge. 139 times, or excuse me, 39 times 8. Well, I can do that. That's 32. Let's see, that's 40 times 8 is 320, so this would be 312. Subtract 312. I don't know, I'm done. 152 minus 312 equals negative 160. So my a sub 1 is negative 160. And now we're ready to bust out the pink pen. Let me do that back up. I'm going to do that up here now. So we're going to go, okay, a sub n equals negative 160 plus n minus 1 times 8. A sub n equals 8n. And then this would be 8n minus 8, so plus 1, plus, wait, 8n. Negative 160 minus 8 is, what did I have a plus here for? Negative 168. Now that just does not look right. I mean, that just bothers me. So what I'm going to do is I'm going to plug in 35 and see if that's right, because I really don't think that's right. So 8 times 35 minus 168. Now, when I do this, I'm hoping that this turns out to be 112. Yes! And even if I did 40, it's right. 8 times 40 minus 168. This better be 152, and it is correct. So it may not look right. It may look weird, but that's the rule that generates those sequences. So if you listed out the first 40 numbers, the 40th number would be 152, and the 35th number would be 112. And the first number would be negative 168. All right, let's go. Let's just do this. D equals, we know we got to find D. So we're going to go 522 minus 510 all over 103 minus 100. Well, I know the denominator is 3. The numerator is 12, so this is just 4. So now I'm going to use, I don't know, this one looks really easy to use. I'm going to use this one. So a sub 1, which is 510, or excuse me, a sub n, which is 510. We're going to use this, remember, we're going to use that formula. I just erased it. I must have erased it. We don't know a sub 1 plus n minus 1, so our n in this case is 100. 100 minus 1 times 4. Well, 100 times 4 is 400, so this would be 396. We'll subtract the 396, and we get 114. So a sub 1 equals 114. Now we're ready to roll. A sub n equals 114 plus n minus 1 times 4. So this is 4n. That's minus 4, so minus 4 plus 114 is plus 110. Let me check it real quick. So 4 times 103 plus 522. Oops. Plus 110 equals 522. And then 4 times 100 plus 110. And hopefully this is 510. There we go, 510. All right, 2 left, kids, and we are finished. Let's do D. D equals, stay positive in your life, stay positive with your number, 48 minus 40. I always just pick the big one minus the small one. And then 88 minus 120. Notice here I don't have a choice, right? I went here. Oh, I did that backwards. You guys should be yelling at me. You guys should be yelling at me hard. So I'm going to take these and subtract them. So 120 minus 88. I was so keyed in on the numbers. And the ends are the thing that go on bottom. But since I went in this direction, I also have to go in this direction. So this is going to be 40 minus 48. You just got to be really careful. You always go in the same direction. So what is that? 20 and 12, 32, divided by negative 8. So this is negative 4. So D is negative. And you'll notice, if the 48th term is bigger than the 48th term, it's going down, going down. Okay, now we're going to find a sub 1. So I'm going to just use this one because it's a little bit easier. 120 equals a sub 1 plus n. Oops, we know n is 40. Minus 1 times negative 4. So let's see. 40 times 4 is 160. So this would be 156. But negative 156. We're going to add 156 over. And what does that give us? 276 equals a sub 1. That just does not seem right. I don't know if I did my math right, but we're going to find out in a minute. 276 plus n minus 1 times negative 4. A sub n equals negative 4. Now this is going to be positive 4 plus 276 is plus 280. Let's check that. So negative 4 times, let's see, which one do we want to use? 40? Negative 4 times 40 plus 280. Now hopefully this is 120. And then negative 4 times 48 plus 280. And hopefully this is going to be 88. Yes. And I know you can't see that, but there we got it. All right, we got one last one, kids, and then we're done. This is a long video. Oh my God, look at the size of these numbers. It's so scary. Oh my God, I'm going to do it. Oh, it's not a big deal. D, we're going to subtract the terms. Big minus small, 307 minus 279, all over. Got to go in the same direction. So 975 minus 979. So it looks like they're getting smaller again, so clearly we're going to have negative. What is this? Negative 4 down here. What is it? 307. 7 and 21 is 28. So this looks like my D is negative 7. All right, so my D is negative 7. I don't know. Maybe this is easier to use. They're both ugly as heck. So we're going to put 307 in the left. A sub 1 equals, oh, not equals, plus 975 minus 1 times negative 7. Yeah, I'm not even doing that math. So this is going to be 307 equals a sub 1. I know it's negative. So 976 times negative 7 equals minus 6832. And then we're going to take 307 and we're going to add 6832 because we got to add it over, right? We're going to add it over to the other side. And we get 7139. So a sub 1 equals 7139. Holy crap. Let's do a different color. So a sub n, let me get this up, equals 7139. Why do I think that's wrong? I think my answer key is wrong. I don't think I made a mistake. We're going to find out if I made a mistake because my answer key has a different answer. I was just looking at it. N minus 1 times negative 7. So this gives me a sub n equals negative 7n. And this is plus 7. So 7139 plus 7 is 7146. All right, we got to check that because that definitely doesn't look right. So what we're going to do is we're going to plug in 975. So we're going to do negative 7 times 975, and then we're going to add 7146. Now, if it's right, it turns out to be 307. I don't think it's going to be. It's 321. So I made a mistake here. I think my answer key is correct. And I know where I made my mistake. Hopefully you saw it. Do you see when I did this? I think when I put this in my calculator, I think I put this in wrong. So I don't think this is correct. I think I put 976. I should have put 974. See how I put 976 here? I should have put 974. So that should be negative 6832. Isn't that what I had? Oh, wait. I should have put 974. And this would be negative 6818. Negative 6818. And then negative, we're going to add 6818 here. So this is wrong. This is wrong. And then this is wrong. So, 307 plus 6818 equals 7125. I think this is right. So 7125 goes here. And then when I add this, remember this is a plus 7, so this gives me 7132 here. So now I'm going to check it. Last one, let me just slide this over a little bit. I'll make sure it's not behind my head. Now I'm going to check it. I'm going to go to my calculator. Say, hello, calculator. I'm going to type in negative 7 times 975 plus, and I don't remember the number, 7132. Now, if it's right, I'm hoping it's 307. Yes. And I'm going to do the same thing one more time, but this time I'm going to do 979. And I'm hoping this is 279. Yes. All right, so we got it right that time. So you got to be careful. I put that in wrong there. All right, that's it, kids. That's the end of sequences and series. That's some hard stuff right there. We will work on it, okay? Okay. Catch you on the flip side. Goodbye. Oh, hit subscribe.